HIV is human immunodeficiency virus. HIV is classified as a retrovirus. Structurally, HIV takes a rough spherical shape. The retrovirus contains two positive single-stranded RNA housing the virus's genome, which is contained in the cone-shaped protein capsid. The function of this capsid is to protect the RNA from being digested by its own nucleases. This capsid also encloses other important enzymes and proteins such as reverse transcriptase. The phospholipid membrane and the viral protein matrix form the outer shell of the HIV virus. This shell encases the glycoproteins which are responsible for the attachment and transmembrane transportation of the virus. Unlike other viruses, a retrovirus uses the enzyme reverse transcriptase to produce DNA from the virus's own RNA, and then replicates by incorporating its integrated DNA into the host cell's genome to be replicated. Reverse transcription of HIV is very sloppy due to the lack of the DNA polymerase, which corrects errors made in replication, and this can create various mutations of the HIV strand. Some defective strands that cannot replicate, while some can become very resistant to antiviral and antibiotic medication. This graph shows the evolutionary tree of some of the HIV strains that have been discovered, all coming from a common ancestor. Evidently, many different strains mutate from the sloppy replication of the HIV virus. Antiviral medication works by limiting the virus's growth and development. One antiviral drug used to manage HIV is a protease inhibitor, which inhibits the cutting and assembly of the viral DNA. But as stated earlier, the unstable replication of HIV leads to many strands of HIV becoming resistant to these antiviral drugs. Due to HIV being a viral disease, antibiotics cannot treat it directly. The significance of the antibiotic is that it is necessary for HIV-positive people to take them because immune system becomes compromised and therefore ineffective in fending off everyday infections such as salmonella. HIV limits the lymphocyte recognition, depressing the body's effectiveness in fighting and memorizing the invading pathogen, which can lead to multiple attacks by the same infection or disease. Due to the sloppy replication of reverse transcription and the mutant strains caused by it, patients taking any single antiviral drug will likely have some mutant viruses that it happens to be resistant, and therefore survives the onslaught of the drug, and then replicates itself, creating many resistant strains of HIV. In the 1990s, protease inhibitors, which target viral assembly by inhibiting the activity of protease, were combined with reverse transcriptase inhibitors to form a cocktail which produced highly active antiretroviral therapy, also known as HART, to undetectable levels. HART are the aggressive treatments used to suppress HIV replication and progression. Due to the rapid mutations of HIV, the mutated strands are more resistant to the antibiotics than the previous generations were. Triple cocktail therapy is a combination of 3 antiretroviral drugs that are used to slow the progression of HIV. The triple cocktail therapy works by administering several different types of antiviral medication to the patient instead of just one. The chances are much lower that the infected host viruses are resistant to antiviral drugs. Although multiple drug-resistant HIV strains do eventually evolve, triple cocktail drugs delay their evolution. The triple cocktail medication consists of nucleoside analog reverse transcription inhibitor drugs and protease inhibitor drugs. The drugs can drastically reduce the concentration of the virus in the bloodstream to undetectable levels by affecting enzymes in the virus itself, inhibiting its replication. The drugs do not completely eliminate every virus in the body due to the resistant strains being created by sloppy but rapid reverse transcription. Soon after the therapies reach a maximal point of effectiveness, they have to be immediately replaced by another therapy to offset the marked drop in effectiveness that is usually seen. The maximal point of therapy effectiveness corresponds with the lowest amount of virus load. Once the therapy reaches a point of maximal effectiveness, oftentimes a new strain of HIV that is resistant to the current therapy evolves, requiring the implementation of a new set of effective therapies. The evolution of a new strain results in a marked increase in virus load, which occurs after reaching a point of minimal virus load. The evolution of a new strain resistant to the therapy is responsible for providing this image the parabolic shapes it possesses. Therefore, the administration of triple cocktail therapy needs to constantly be revised to maintain its effectiveness.
Yeah, just letting you know, if you do have a sexually transmitted infection or disease, it's okay, just protect yourself. We have a problem, times are wasting, and we've been patient. HIV, don't feel isolated, don't wait to face it, cause you can make it. Spread the word, don't spread disease. Help find a cure for STDs and cure for AIDS and STIs. It's time to stand and recognize. Let's stand and fight it. It might sound bad, but it may not be, so go ahead, get tested for HIV. It's not too late, nah, don't say la vie. There's help and the cure is on the way, you'll see. If you're diagnosed and you're with someone who you find is close, tell them with the right approach and provide them hope. Don't lie to them and keep it secret, especially when you can save their life and help them seek the treatment. Even if it's someone who you aren't married to, or if you're there for them and they aren't there for you. Wouldn't you rather have someone who would care for you? Treat your body right, yeah, it's only fair to do. We have a problem, times are wasting, and we've been patient. HIV, don't feel isolated, don't wait to face it, cause you can make it. Spread the word, don't spread disease. Help find a cure.